So in this section, we are going to learn about sensors and the sampling survey. Sensors, any of you might already familiar with these sensors. It's called sensors because all members in a target populations were corrected. So it's usually employed to describe the distribution of disease in populations or health status, or to establish some reference value to physiological or biochemical marker. Also, sensor can be used to conduct a screening for prevention of disease. For example, China has launched 6 times of national screening for diabetes during 1980s to 2010. So this kind of the survey can help to understand the prevalence rate of a particular study, and because it's a sensor, all members in a particular region are included. So the selection bias is usually very rare. There are some principles of sensors. The sensor's primary aim is to find all patients and to treat them. So in order to be more cost-effective, the prevalence rate of a disease in a sensor should be higher so that many of patients could be found. Both the sensitivity and the specificity of diagnosis criteria should be high, and the manipulating technique of examination should be simple and conventional in the field. In order to perform our sensors, we need enough manpower to research funding, material equipment to find patients in sensor, and the necessary treatment in time also should be considered. And therefore, as you can see, the advantage of sensor can be they have very rich data source. They can describe the entire epidemic character because they include all the populations, and also can help to investigate the relationships between the multi-factors and the disease. But the disadvantage of the sensors are also apparent. For example, it's very expensive and need many manpower. It's time-consuming, and for those diseases that have low prevalence rates, it's very difficult, or I would say it's not cost efficiency to use sensors, because even though you collect all populations in your sensors, you might only find few cases of disease that you are interested. And it's very hard to control the quality because there are so many objects in sensors, and usually the sensor should be finished in a short time, and some objects might be missed and didn't reply. So another common method used in cross-sectional study, as we have mentioned before, is called sampling survey. It's called sampling survey. So what is sampling survey mean? The sampling survey is to select a representative sample from the entire study population and to conduct a survey. The basic principle in sampling survey is representative and large sample size. So in the sampling survey, we have to use a sampling method in order to select the study samples. So here are 5 commonly used sampling methods, including sampling random sampling, systematic sampling, stratified sampling, cluster sampling, and multi-stage sampling. First one, simple random sampling. So this method randomly selects our sample for the defined total populations, and this sampling can be done using random numbers, either from textbook or computer software. So as long as it's a random, the selected samples, no matter what random method you use, as soon as it can be randomly selected from the entire study populations, it will work. The second method is called systematic sampling. So let's look at this figure. Imagine that we have these entire populations, and we can divide our entire population into different sampling intervals, and then we select each 1 or 2 study participants from each sampling intervals. So let's look at this example. We try to select 12 people from the entire 1,200 study populations. So the first step we can do is we can calculate how many sampling interval we are going to use. So we can divide 1,200 by 12. So which means we actually need need 12 sampling intervals, and each the sampling interval should contain 100 people. So from this each 12 sampling interval, we can select one person from each interval. So we can select in total 12 people from these 12 sampling intervals. So the next sampling method is called clustering sampling. So cluster sampling means we first divide the entire population into different clusters. For example, in this figure, we classify the hospital into different volume hospital, including large hospital, medium hospital, and small hospitals. And then we can do sampling between these 3 levels of hospital. Another sampling method called stratified sampling. So this is a bit similar to the previous cluster sampling. So what different to cluster sampling is that in the stratified sampling, we made the stratification by different category. So this category usually are those characters that are very important in the association between outcomes and exposures. For example, we can stratify the population by different age, by different gender, by different education level. So we can name select population for each stratification or each category. So the end of this stratification is that we can be able to select people from different age or different gender. So this sampling method can make our population more representative. And another issue in the sampling survey is that we need to know how many samples we're going to collect in order to satisfy the statistical power. So there are several formula actually can be used to calculate this sample size. So as we can see on the page 39, we can use this formula to calculate the sample size. So the advantage of sampling survey is it's very easy and safe and time saving, and the workload is much reduced compared to the sensors. And it can also study several factors or outcomes at one time. This sampling survey also can provide early clues for hypothesis generation, and it's also usually commonly used as the first step for a potential hypothesis. And the advantage is that during the study collection, the sampling error can occur and it's hard to avoid. And we need to design the study methods in a more complex manner, because in the sensor study design, we can easily try to include all the study populations. But in the sampling survey, we need to perform this sampling, randomization sampling, in order to select those representative sampling for our study. And it's also not applicable to disease with low prevalence and excessive variability.